So in this Lab 9 pre-lab video 1 of 3, simple linear regression, we are going to start out by reviewing regression calculation. So that is the content of this first video, video 1. In our second video, we're going to be introducing a new concept, homogeneity of variance, when we describe the assumptions of simple linear regression. So we have some old assumptions that will be familiar, and then we're going to add our homogeneity of variance. In the third video, we're going to explore simple linear regression using SPSS. And then once we get into lab, we're going to do a little bit more exploring and practicing with our simple linear regression and get into the simple linear regression lab assignment. So simple linear regression has two main purposes. The first is to predict or estimate from one known data set to another data set. So for the example of income versus education, we can, with simple linear regression and our regression equation, predict if we have our education data and our income data, and I have another set of data for income, I can predict for my new set of data my education level based on my old set of data, using my y prime equals a plus bx. I can also explain with simple linear regression. I can explain the variance seen within my dependent variable based on my independent variable. So what this means is I can decide, using simple linear regression and my coefficient of determination, r squared, how much of the results I'm seeing in my dependent variable are because of my independent variable. So what percentage of my variance is explained by the independent variable versus a myriad of other variables that might be explaining it. So if we're talking about income and education, I can decide, using simple linear regression, how much of my income level is actually because of my education level versus because of other variables. So simple linear regression and our correlations are very, very connected. In fact, our simple linear regression is built off of our correlation, and we use our correlation calculation or our equation to actually find our r squared. So, and this is how we find our coefficient of determination and are able to explain variance based on our independent variable. And then our regression equation, y prime equals a plus bx, can help us to predict from one data set to another. So given a set number of x's and y's, I can predict any other y based on a new x using my b and a equations. So we're going to do this now. I'm going to give you a brand new data set. Feel free to pause and do these calculations on your own and then check your work against mine after you unpause. So once again, just like all other calculations in this course, you're going to be given this table, and you'll be able to calculate sum of x, sum of y, sum of x squared, sum of y squared, and sum of x and y. And then we'll just be able to plug and chug into both our correlation equation and our y prime equals a plus bx equation based on our a and b equations. So all it is plugging and chugging. So go ahead and pause and then unpause when you have completed this chart. So here is my completed chart. Check your answers against mine, pause, and recalculate if something looks wrong, but it's also possible that my calculations went wrong somewhere, so definitely reach out if you believe that's the case. And now I'm going to go ahead and use this information to plug and chug in both my correlation equation and my A and B equation. So now's another chance to pause, do these calculations for yourself, just plug and chug, and then check your answers against mine. So as I went through and plugged and chug my sum of x, sum of y, sum of x squared, sum of y squared, sum of x and y into my correlation equation, I came up with an R, or my correlation coefficient, of 0.972. So that's a pretty high correlation. I'm saying my x is very highly correlated and positively correlated with my y and vice versa. In order to find my coefficient of determination, all I have to do is square that number. And I have my correlation, or my coefficient of determination, is 0.945. And that is a high coefficient of determination. And with that R squared, what I am doing, what I can say based on this R squared, is that 95% of the variance seen in my dependent variable, or my y, is because of my x, or my independent variable. So if I move along now, I can move on to my prediction. So I've explained how much variance is seen in my dependent variable based on my independent variable, and now I can use my old data set to predict new y's. So go ahead and check your work against mine, but my B came out to be 3.27, and my A came out to be negative 19.23. And I can go ahead and plug that in to my regression equation. And so any new x I can come up with, I can plug it into the equation and estimate what my y would be based on the information given in my old equation, or in my old data set. So there are two purposes of regression: to explain and to predict.